Hello everyone, welcome back to 10th Physics online sessions. In the previous video, we have discussed about Ohm's law and resistance and equivalent resistance in the parallel connection as well as equivalent resistance in series connection. In this video, I would like to discuss about the main important law in your 10th as well as it will be continued in your further studies like intermediate and engineering. The law is Kirchhoff's law. What is the law? Kirchhoff's law. The scientist Gustav Kirchhoff proposed a law regarding to the current. What is the need to propose this law? Actually, in the previous class, we discussed about Ohm's law. According to Ohm's law, we can find voltage and current as well as resistance of any conductor when it is a single path or in single conductor. For example, if you take Ohm's law, to find out current, what is the formula we used? Formula V equal to IR, as well as we used the formula I equal to V by R. So by using this formula, by using the ratio of voltage and the ratio of the resistance power, we can get the value of current, how much current that flows through a circuit. But this formula only applicable for a single conductor, means a single conductor. I can find out what is the current flow through this conductor by using formula I equal to V by R. And if there are more than one conductors, means there are number of the conductors. This is one of the conductor, this is one of the conductor, this is one of the conductor, and this is another conductor. They are meet at a point O. Then how we can find out the current flows through this junction by using Ohm's law? We have to find out individually for this and for this and for this and for this. It is so difficult, you know. That's why to make it easy, Gustav Kirchhoff in the year 1845, that scientist Gustav Kirchhoff belongs to German. He is a German physicist. He proposed a law. That law is called Kirchhoff's first law. It is also called as a Kirchhoff first law, and another name is junction law. What is the another name? Junction law. He proposed junction law. What is junction law states in this video we are going to learn. Junction law states that, what is the statement of junction law? The total current into a junction equal to the total current out of the junction. It is the statement, it is the law of Kirchhoff's first law. Look at here. What is the statement I am going to explain now? For example, this is a conductor and this is also another conductor, this is also another conductor, this is also another conductor, this is also another conductor. These conductors, these wires are connected at a point O, so it is a junction. So junction O. If we use Ohm's law, we have to find out current for this. It is the wire 1, wire 2, wire 3, wire 4 and wire 5. So these are the 5 wires, 5 conductors. So by using Ohm's law, we have to find out current individually for 1, for 2, for 3, for 4 and for 5. But by using Kirchhoff's law, we can find out the total current that passes through the junction by using Ohm's law. Look at here. What Ohm's law states that? The total current into a junction. For example, I will take in the conductor 1, the current goes into the junction. So I consider it as I1. and another wire 2, it is also go inside of the junction, it is called I2. You can write anywhere. If you want to write out of the junction, you can write. Okay, it is also, it is goes out of the junction. This is I3, and wire conductor 4 goes into the junction, it is I4, and conductor 5, the current flows out of the junction, it is I5. According to this picture, I would like to explain this law. Look at here, the total current into the junction. So the total means we are doing total plus addition. So what is the total current that go into the junction? Tell me from the picture. Yes, I1 into the junction, and I2 also into the junction, and I3, it is not into the junction, it is out of the junction. I4 also into the junction, is equal to the total current out of the junction. This is equal to the total current out of the junction. What is the current out of the junction? Equal to the, what is the current go out of the junction? This I3 and I5. So this is the statement of the junction. It is very easy. Look at here, the total current into the junction. So this is the junction point O. The total current goes into the junction. What is the current goes into the junction? I1, I2 and I4 is equal to the current out of the junction. What are the current goes out of the junction? In the conductor 3 and 5, I3 current and I5 current. So I3 plus I5. So this is the Kirchhoff's first law. It is also called as a junction law. We can derive this in another form. Look at here, the algebraic sum of the current. So algebraic means we are showing that equation with plus and minus values. That is called algebraic. So look at here, the current which is go inside, I will take in that values as a plus values, adding into the junction, adding to the junction. So I1 is a plus, I2 is a plus, and I4 is also plus, because the current flows inside, adding. Leaving means subtracting, leaving. So I will take them as a minus values. So these are algebraic values. Okay, the algebraic sum of the current at a junction is 0. Look at here, algebraic values are what? I1, what is the I1 value? Plus I1, sorry, plus I1 plus I2 plus I4. Then what is the value of the I3? Minus. So minus I3. What is the value of I5? Minus I5 is 0. So this is the another form of the Kirchhoff's law. What is the Kirchhoff's law? Another form? The algebraic sign conventionals like plus and minus. The algebraic sum of current. Sum means total. Total algebraical values of current total at a junction is 0, so we can write Kirchhoff's first law like this also. What is the algebraic sum of the currents? I1 plus I2 plus then I4 minus I3 minus I5 is equal to 0. From this we can derive this statement. Look at here, I1 plus I2 plus I4. If I bring these minus values to that side, then equal to I3 plus I4. So we get this statement. Look at here, this is about Kirchhoff's law, and it is also called as the law of conservation of current. It is also called as a junction law, also called as the law of conservation of current. Why? Because at here, as we discussed in the before, energy cannot be created and cannot be destroyed. like that current cannot be created and cannot be destroyed. At here the current what is going into the junction is not destroyed, that is equal to the leaving the junction. So that's why it is called as the law of conservation of current. This is about Kirchhoff's law. It is very easy law and important law for your further studies. In the next video I would like to teach about Kirchhoff's second law. It is also called as a voltage law. So we will discuss in the next video. Thanks for watching. Keep smiling. Take care. Bye bye.